Children, now let us recall the definitions of all the trigonometric ratios. The first one, sine theta is equal to opposite side by hypotenuse. Next, cos theta is equal to adjacent side by hypotenuse. Next, tan theta is equal to opposite side by adjacent side. Next, cosec theta or cosecant theta is equal to hypotenuse by opposite side. Next, sec theta or secant theta is equal to hypotenuse by adjacent side. Next, cot theta is equal to adjacent side by opposite side. Reciprocal relation between t ratios. Children, relation between trigonometric ratios and their reciprocals are given below. Children, we know that cosecant theta is the reciprocal of sine theta. So, it can be written as sine theta is equal to 1 by cosecant theta, or cosecant theta is also equal to 1 by sine theta. From this, we can conclude that the product of sine theta and cosecant theta, that is sine theta into cosecant theta, is equal to 1. Similarly, cos theta is the reciprocal of secant theta. So, it can be written as cos theta is equal to 1 by secant theta, or secant theta is equal to 1 by cos theta. From this, we can conclude that cos theta into secant theta is equal to 1. Similarly, we know that cot theta is the reciprocal of tan theta. So, it can be written as tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan theta. From this, we can conclude that the tan theta into cot theta is equal to 1. Children, we need to remember all these reciprocal relations because we are going to use these relations while solving the problems. Next, quotient relation between trigonometric ratios. Children, we know that tan theta is equal to opposite side by adjacent side. Now, let us divide both numerator and denominator by the side hypotenuse. Then we get tan theta is equal to opposite by hypotenuse whole by adjacent by hypotenuse. Children, we know that opposite side by hypotenuse is equal to sine theta and adjacent side by hypotenuse is equal to cos theta. Therefore, tan theta is always equal to sine theta by cos theta. Next, we know that cot theta is the reciprocal of tan theta. So, it can be written as cot theta is equal to 1 by tan theta. Now, let us replace tan theta by sine theta by cos theta. Then we get cot theta is equal to 1 whole by sine theta by cos theta. Now let us take the reciprocal to it. Then we get cot theta is equal to cos theta by sine theta. Children, these two relations are called quotient relation between t ratios. Note, children, the symbol sine theta is used as an abbreviation for the sign of the angle theta. Next, sine theta is not the product of sine and theta. It means sine theta is not equal to sine into theta. Next, sine separated from theta has no meaning. Children, these interpretations follow for the other trigonometric ratios also, like cos theta, tan theta, cosecant theta, secant theta, and cot theta. Note, children, please notice that sine theta whole square is always equal to sine square theta, but sine theta whole square never be equal to sine theta square, or sine theta whole square never be equal to sine square theta square. Next, similarly, tan theta whole cube is always equal to tan cube theta, but it never be equal to tan theta cube or tan cube theta cube. Next, some important points about trigonometric ratios are given below. The first one, each trigonometric ratio is a real number. It means it is always a constant and has no unit. It means there are no units for the trigonometric ratios. Next, the value of each of the trigonometric ratio of an acute angle does not depend on the size of the triangle. It depends only on the acute angle. Next, the values of the trigonometric ratios of an angle do not vary with the length of the sides of the triangle if the angle remains the same. Children, now let us solve some examples based on trigonometric ratios. The first one, in a triangle ABC, right angle at B, if AB is equal to 15 centimeters and AC is equal to 17 centimeters, find all the 6 trigonometric ratios with respect to an acute angle A. So, let us start. Children, from figure, let us name the sides of a right angle triangle with respect to an acute angle A. Children, AC is the hypotenuse since it is the opposite side to a right angle. Therefore, the hypotenuse AC is equal to 17 centimeters. Next, AB is the adjacent side since it is next to an acute angle A. Therefore, the adjacent side AB is equal to 15 centimeters. Next, the side BC is the opposite side since it is opposite to an acute angle A. So, the opposite side is equal to BC. Children, first we need to find the length of the opposite side. Children, how do we find? Yes, we can find it by using the special property of a right angle triangle, that is Pythagoras theorem. Next, in triangle ABC, AC square is equal to AB square plus BC square by Pythagoras theorem. Now let us substitute the values of AC and AB in this equation. Then we get 17 square is equal to 15 square plus BC square. Now let us take the squares of 17 and 15. Then we get 289 is equal to 225 plus BC square. Now let us shift 225 from RHS to LHS. Then we get 289 minus 225 is equal to BC square. By subtracting these two numbers, we get 64 is equal to BC square. Now let us shift square from RHS to LHS. Then we get square root over 64 is equal to BC. Children, what is the square root of 64? Yes, it is 8 centimeters. Therefore, the length of the opposite side BC is equal to 8 centimeters. Children, from the triangle ABC, the hypotenuse is equal to 17 centimeters. The opposite side is equal to 8 centimeters and the adjacent side is equal to 15 centimeters. Now, let us find the values of all the 6 trigonometric ratios with respect to an acute angle A. Children, we know that sine A is defined as opposite side by hypotenuse. So, the value of sine A is equal to 8 by 17. Next, cosecant A is defined as the hypotenuse by opposite side. So, the value of cosecant A is equal to 17 by 8. Next, cos A is defined as adjacent side by hypotenuse. So, the value of cos A is equal to 15 by 17. Next, secant A is defined as the hypotenuse by adjacent side. So, the value of secant A is equal to 17 by 15. Next, the tan A is defined as opposite side by adjacent side. So, the value of tan A is equal to 8 by 15. Next, cot A is defined as adjacent side by opposite side. So, the value of cot A is equal to 15 by 8. Next, if tan A is equal to 4 by 3, then find all the other trigonometric ratios with respect to an acute angle A. Children, in this problem, the value of tan A is given. Now, we need to find the values of the remaining 5 trigonometric ratios. So, let us start. Children, let ABC be a right angle triangle and right angle at B. Now, let us name the sides of a right angle triangle ABC with respect to an acute angle A. They are opposite side is equal to BC since it is the side opposite to an acute angle A. Next, adjacent side is equal to AB since it is the side next to an acute angle A. Next, the hypotenuse is equal to AC since it is the side opposite to right angle. Now, according to the problem, the value of tan A is equal to 4 by 3. Children, how do we define tan? Yes, tan is defined as opposite by adjacent. Now let us replace opposite and adjacent with the sides BC and AB. Then we get tan A is equal to 4 by 3 which is equal to BC by AB. Now let us take BC is equal to 4K and AB is equal to 3k. Children, here k is a constant. We need to take k since 4 by 3 is the ratio of the sides of a triangle. Now let us find the length of the third side AC. Children, we know that in triangle ABC, AC square is equal to AB square plus BC square by Pythagoras theorem. Now let us substitute the values of AB and BC in this equation. Then we get AC square is equal to 3k whole square plus 4k whole square. Now let us take the squares for 3k and 4k. Then we get AC square is equal to 9k square plus 16k square. Now, by adding these two terms, we get AC square is equal to 25k square. Now, let us shift the square from LHS to RHS. Then we get AC is equal to square root over 25k square. Children, we know that the square root of 25 is 5 and the square root of k square is k. Therefore, the length of the third side AC is equal to 5k. Children, from figure, the hypotenuse is equal to 5k, opposite side is equal to 4k and adjacent side is equal to 3k. Now let us find the values of the remaining trigonometric ratios. Children, we know that sine A is defined as opposite side by hypotenuse, which is equal to 4k by 5k. Now let us cancel k from both the numerator and denominator. Then we get sine A is equal to 4 by 5. Next, cos A is defined as adjacent side by hypotenuse, which is equal to 3k by 5k. Now let us cancel k from both the numerator and the denominator. Then we get cos A is equal to 3 by 5. Next, children, we know that cosecant A is the reciprocal of sine A. So, let us take the reciprocal to the 4 by 5. Then we get cosecant A is equal to 5 by 4. Next, we know that secant A is the reciprocal of cos A. So, let us take the reciprocal to the 3 by 5. Then we get secant A is equal to 5 by 3. Next, we know that cot A is the reciprocal of tan A. According to the problem, the value of tan A is given that 4 by 3. Now let us take the reciprocal to each. Then we get cot A is equal to 3 by 4. Next, if sin Q is equal to 24 by 25, then find the value of sin Q cos P plus cos Q sin P, where angle R is 90 degrees. Children, in this problem, the value of sin Q is given. We need to find the value of this expression. So, let us start. Let PQR be a right angle triangle and right angle at R. Now, let us name the sides of this right angle triangle with respect to an acute angle Q. Children, opposite side is equal to PR since it is opposite to an acute angle Q. Next, adjacent side is equal to QR since it is next to an acute angle Q. Next, the hypotenuse is equal to PQ. Children, according to the problem, it is given that sin Q is equal to 24 by 25. Children, how do we define sine? Yes, we define it as the opposite side by hypotenuse. Now let us replace opposite side and hypotenuse by PR and PQ. Then we get sin Q is equal to 24 by 25, which is equal to PR by PQ. Now let us take PR is equal to 24K and PQ is equal to 25K. Children, here K is a constant. We need to take K since 24 by 25 is the ratio of the sides of a right angle triangle. Children, now let us find the length of the third side QR. We know that in triangle PQR, PQ square is equal to PR square plus QR square by Pythagoras theorem. Now let us substitute the values of PR and PQ in this equation. Then we get 25K whole square is equal to 24K whole square plus QR square. Now let us take the squares for 25K and 24K. Then we get 625K square is equal to 576K square plus QR square. Now let us shift 576K square from RHS to LHS. Then we get 625K square minus 576K square is equal to QR square. By subtracting these two terms, we get 49K square is equal to QR square. Children, now let us shift the square from RHS to LHS. Then we get square root over 49K square is equal to QR. Now let us take the square root for 49 and K square. Then we get QR is equal to 7K. Now let us find the value of cos with respect to an acute angle Q. Children, we know that cos Q is defined as adjacent side by hypotenuse, which is equal to QR by PQ. By substituting the values of QR and PQ, we get 7K by 25K. Now let us cancel K from both numerator and denominator. Then it remains cos Q is equal to 7 by 25. Next, now let us find the values of sine and cos with respect to an acute angle P. We know that sine is defined as opposite side by hypotenuse, which is equal to QR by PQ. Since QR is the side opposite to an acute angle P and PQ is the hypotenuse. By substituting the values of QR and PQ, we get 7K by 25K. Now let us cancel K from both the numerator and denominator. Then it remains sin P is equal to 7 by 25. Next, cos is defined as adjacent side by hypotenuse, which is equal to PR by PQ. Since PR is the side next to an acute angle P and PQ is the hypotenuse. Now let us substitute the values of PR and PQ. Then we get 24K by 25K. Now let us cancel K from both the numerator and denominator. Then we get cos P is equal to 24 by 25. Now let us substitute the values of sin Q, cos Q and sin P in this expression. Then we get 24 by 25 into 24 by 25 plus 7 by 25 into 7 by 25. By multiplying these fractions, we get 576 by 625 plus 49 by 625. By adding these two fractions, we get 576 plus 49 whole by 625. By adding these two numbers, we get 625 by 625. Let us cancel 625 with 625. Then it remains 1. Therefore, the value of sin q cos p plus cos q sin p is equal to 1. Next, in triangle ABC, the right angle at C, if 17 cos A is equal to 8, then show that cosecant square A minus cot square A is equal to 1. Children, in this problem, the value of 17 cos A is equal to 8. We need to prove the value of cosecant square A minus cot square A is equal to 1. Let us start. Let ABC be a right angle triangle and right angle at C. According to the problem, 17 cos A is equal to 8. Now let us find the value of cos A by shifting 17 from LHS to RHS. Then we get cos A is equal to 8 by 17. Now let us name the sides of right angle triangle ABC with respect to an acute angle A. Children, the opposite side is equal to BC since it is opposite to an acute angle A. Next, the adjacent side is equal to AC since it is next to an acute angle A. Next, the hypotenuse is equal to AB. We know that cos A is equal to 8 by 17, which is defined as adjacent side by hypotenuse. Now let us substitute adjacent and hypotenuse by AC and AB respectively. Children, then we get cos A is equal to 8 by 17, which is equal to AC by AB. Now let us take AC is equal to 8K and AB is equal to 17K. Children, here K is the constant. We need to take K since 8 by 17 is the ratio of the sides of a right angle triangle. Now let us find the length of the third side BC. We know that in triangle ABC, AB square is equal to AC square plus BC square by Pythagoras theorem. Now let us substitute the values of AB and AC in this equation. Then we get 17K whole square is equal to 8K whole square plus BC square. Now let us take the squares for 17K and 8K. Then we get 289K square is equal to 64K square plus BC square. Now let us shift 64K square from RHS to LHS. Then we get 289K square minus 64K square is equal to BC square. By subtracting these two terms, we get 225K square is equal to BC square. Children, now let us shift the square from RHS to LHS. Then we get square root over 225K square is equal to BC. Now let us take the square root for 225 and K square. Then we get BC is equal to 15K. Children, now let us find the values of cosecant and cot with respect to an acute angle A. Children, we know that cosecant A is defined as hypotenuse by opposite side, which is equal to AB by BC. Now let us substitute the values of AB and BC. Then we get 17K by 15k. Now let us cancel k from both the numerator and denominator. Then it remains cosecant A is equal to 17 by 15. Next, cot A is defined as adjacent side by opposite side, which is equal to AC by BC. Now let us substitute the values of AC and BC. Then we get 8k by 15k. Now let us cancel k from both the numerator and denominator. Then it remains cot A is equal to 8 by 15. Children, now let us substitute the values of cosecant and cot in this expression. Then we get 17 by 15 whole square minus 8 by 15 whole square. By taking the squares for these two fractions, we get 289 by 225 minus 64 by 225. Now let us subtract these two fractions. Then we get 289 minus 64 whole by 225. By subtracting 64 from 289, we get 225 whole by 225. Let us cancel 225 and 225. Then it remains 1. Therefore, the value of cosecant square A minus cot square A is equal to 1. Hence, it is proved.